Hi everyone, I'm Yogadharani, working as Assistant Professor at Department of Computer Science and Engineering at SNS College of Technology. Today we're going to learn about important topic from evaluation matrices like confusion matrix. Here we know already that machine learning models make predictions, but simply making predictions is not enough. We need to check whether those predictions are correct or not correct. For classification problems, most of the common used tools for evaluating model matrices is a confusion matrix. And today we will learn what is confusion matrix, why do we need it, what are true positive, true negative, false positive and false negative, how do we calculate accuracy, precision, recall and F1 score, where is a confusion matrix used in a real world applications likewise. And for making predictions we need to evaluate the models. For that we have to compare what is the actual outcome and versus the predicted outcome. And today's objective of today's session is we should be able to explain what a confusion matrix is. We should also be able to identify four components like true positive, true negative, false positive and false negative. And then we will use these values to calculate different evaluation matrices. Finally, we will see how confusion matrices are used in real world applications. Now, understand the scenario. Imagine a hospital develop a machine learning model to predict whether the patient has a disease. The model gives two possible predictions like disease or no disease. So suppose the model predicts that a patient has a disease, but how do we know whether the prediction is correct? We compare the model's predictions with the patient's actual medical results. This comparison gives us four possible outcomes, and we represent these outcomes using a confusion matrix. A confusion matrix is a table used to evaluate the performance of a classification model. Uh, it compares actual values with the predicted values. The important advantage is that it does not simply tell us whether the model is correct or wrong. It also tells us what type of mistake the model is making. For example, predicting positive correctly, predicting negative correctly, predicting positive, but when it should be negative, predictive negative when it should be positive. Then this shows, yes, suppose our model predicts whether an email is a spam. We have 100 mails. The model predicts some as a spam, some as a not spam. But we need to know whether these predictions are correct. Here, how can we compare the actual result and predicted result systematically? The solution is confusion matrix. It gives us a simple table where we can clearly see correct predictions and incorrect predictions. Here, confusion matrix is a 2 cross 2 table for a binary classification. It contains four values such as TP, TN, FP and FN. Here, it compares actual class with the predictive classes. So, this is the structure of confusion matrix. The row represents the actual value and the column represents the predicted value. And these are the components of confusion matrix. Here, true positive also represented as TP. This value is positive and the model also predicts positive. Example, patient has a disease, model predicts disease. And the true negative. Here, the actual value is negative, but the model predicts negative. That is true negative. It predicts correctly. That is, the answer is negative, and also the model predicts the answer is negative. And the next one is false positive. Here the actual value is negative, but the model predicts positive. This is represented as false positive. Example, healthy patient does not have a disease, but model predicts disease. This is called false positive, which means the actual value is negative, but the model predicts this as a positive. And the last one is false negative. Here the actual value is positive, but the model predicts negative. The patient has a disease, but the model shows that this patient has a not disease. So this is the example of confusion matrix with our example disease and non-disease. Here true positive is 50, true negative is 35, and false positive is 5, false negative is 10. So the confusion matrix allows us to clearly understand the model predictions. And then accuracy. Accuracy means uh, out of all predictions, how many predictions were correct? And this is the formula of accuracy. And this is the next matrix called precisions. And here precision is mm, uh, means out of all cases predicted as positive, how many is actually positive? And this is the formula for precision. And then recall and F1 score, which means out of all positive cases, how many did the model correctly identify as a recall? And this is the formula for recall. And F1 score means F1 score combines precision and recall into one measure. And this is so the formula for F1 square. And advantages of today's session is we seeing about confusion matrix, right? So this is easy to understand, which gives detailed results, and it identifies the error, and it supports multiple matrices like accuracy, precision, recall, F1 score, and it helps compare models. And these are the common applications of machine learning, where we use also use confusion matrices. And by the end of the session, today is about what is confusion matrix, what are the components in confusion matrix, and confusion matrix is the foundation for evaluation matrices of a classification model. Once you understand what is true positive, true negative, false positive, and false negative, you can easily understand precision, accuracy, recall, and F1 score. Thank you. Hope today's class was interesting. If you have any doubts, comment me. Catch you in another video.